Now considering things that are called complementary events. So the definitions here is simply that, remember, if A is an event, then A prime, or A with a little apostrophe actually, is called the complement of A. And what it really means is it means not A. Okay? Now, to test if two events are complementary, you simply take the you look at the conditions of complementary events, because the conditions for complementary events is that probability of A plus probability of not A must add up to the sample space, right, which is 1. So I'm going to show you some quick examples. Let's look at the probability of getting a 2 in a regular roll enrolling a regular die. Okay, the probability of getting a 2 over there, you should know, is 1 out of 6, right? Then we say the probability of 2 complement. The probability of 2 complement. What is the probability of not getting a 2 or getting something other than 2? And as you know, everything besides 2, there are 5 other observations in the sample space, which is 5 out of 6. Okay? Now, if I have to ask you to test whether the probability of getting the condition that makes these two events complementary is essentially when I test for it and I say probability of 2 plus the probability of not 2 is equal to 1 out of 6 plus 5 out of 6, which is essentially equal to 1, and therefore this must be complementary, right? Now let's look at a few other examples of complementary events. Let's take probability of drawing a king. Okay, in drawing a king from a normal deck of 52 cards. So you know your sample space is going to be 52, and you also know there are 4 kings in there. Then if I ask you what's the probability of not getting a king, okay, because the complement of king is not king. The complement of king is not king. It's as simple as that. How many not king cards are there? Well, there's 48 out of 52. Is king and not king complementary? Well, certainly, because if you add 4 out of 52 and 48 out of 52, it is exhaustive and it gives you the entire sample space, and therefore it's considered complementary events. Okay. Now, let's give you another example. I'm going to make things a little bit complicated here. I'm going to say I've got a class of 5 students, okay, and in the class of 5 students, I've got Jenny, I've got Hafer, I've got Karnit, I've got I've got Kyle, and I've also got Azar. Right, and so I've got these 5 students, and I'm going to ask you, is Hafer the complement of Jenny? Okay, another way of saying this is, does Hafer constitute not Jenny? Now the reality is, the condition for something to be complementary is that if that thing is the complement, then the probability of that complement occurring, right, must, with the sum of the event occurring, must add up to 1. And that's how we test for it being complementary events. Now, the answer to this question is Hafer is not the complement of Jenny. If I'm saying, does Hafer represent not Jenny, or is Hafer not Jenny? Jenny is the event, right, which is a chance of 1 out of 5. Hafer, if I have to draw her name from a hat that is shaken at random, then her probability is also 1 out of 5. When I add 1 out of 5 with 1 out of 5, I don't get to I don't get 1. I don't get 5 out of 5, so they are not complementary events. For them to be complementary events, it means if I take this probability and I add this probability, they must add up to 1. Now, when we have that challenge, the question then to ask is, so what is the complement of Jenny? It is everything, listen carefully, it is everything that is not Jenny. And that's in the sample space. So everything that is not Jenny, Carnit is not the complement of Jenny. Heifer is not the complement of Jenny. Although none of them are Jenny, they are not the complement for statistical purposes in the sample space of Jenny. So what am I saying? I'm saying that the complement is Heifer, Carnit, Kyle, and Azar. The complement is Heifer, Carnit, Kyle, and Azar. This is only relevant to say that the probability of getting Heifer or Carnit or Kyle or Azar is 4 out of 5. And when I add 1 out of 5 with 4 out of 5, I get 5 out of 5. And so essentially, Jenny, getting Jenny, the probability of drawing Jenny's name from a hat in a random competition is 1 out of 5. The probability of getting Jenny complement, right, which can be written either with this or with a line straight on top, either or. We'll use the apostrophe for now. Oops. We'll use the apostrophe over there. And Jenny complement means everything besides Jenny. That's the probability of Heifer, or getting Carnit, or getting Kyle, or getting Azar. Any of them. And the probability of these occurring is 4 out of 5. When I add the two, I get 5 out of 5. Okay, so that's how you test if events are complementary. You simply add the probability of the two events, okay? And if they add up to 1, then you say the events are complementary of one another. Okay, so I think that gives us a basic understanding of complementary events, and I hope that you understand the test thereof, and that you know if I'm in a crowd of 10,000 people and I'm Imaad, the complement of Imaad is the other 9,999 people in there. Okay, that's how we do complementary events.